Astronomy Cast, episode 506. It's not aliens until it's aliens. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser, Cain, publisher of Universe Today. With me, as always, Dr. Pamela, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey Pamela, how you doing?
I'm well, how are you?
Good, we're here in the same room, actually interacting. So if it all sounds so much more fluid and natural, it's because we can actually talk to each other.
Well, we can always talk to each other, but we're in the same place and there's no weird internet noise and stuff and things and dropped bits.
Right.
It's just dropped sound waves.
Now, you sometimes warn us that you might have a tornado flowing through. Where we're recording, there might be fireworks going on at some point in the middle of this episode. Well, we're in Alabama for ThinkerCon. Hopefully we're going to see some of you tomorrow night when we eat dinner under a rocket.
Which will have been 2 nights earlier.
When you get this, it will have already happened. That dinner will have already happened. But yeah, it's great. And it's wonderful to hang out in person. And it's been wonderful just to hang out with a lot of people. All right, well, let's get on with this week's episode. So the big news, of course, over the last couple of weeks, last month, is the assertion that Oumuamua, this, of course, interstellar asteroid / comet, might be a interstellar probe, a solar sail sent by aliens to study planet Earth. Pamela, is it aliens?
No.
Oh, I want it to be aliens.
Well, we all did. It had that perfect sci-fi thing going for it. It's cigar-shaped. It came from another...
Rama-shaped. It's Rama-shaped.
It's Rama-shaped.
Yeah.
It's Rama-shaped.
Yeah.
And we wanted it to be true. And what led so many news outlets down that rabbit hole was a publication that pointed out that its motion isn't consistent with purely orbital motion, which means something must be accelerating it.
Right. And so, to give people background, like the thing that was weird about Oumuamua was you would expect it to have a very smooth motion as it was moving through the solar system.
Right.
And instead, it was having some kind of acceleration that was beyond what astronomers were expecting. And it wasn't a lot. It was a teeny tiny little amount, the kind of thing that would be easily explained if it was a comet, but it wasn't a comet because they didn't detect some kind of coma or tail or anything like that.
And this is where the geography becomes so amazingly important with this object, and where when someone says, oh my God, it's aliens, the answer is not aliens. Until, of course, it's aliens, which will happen someday. But you have to rule out all the usual suspects.
And I think why this event rankled a lot of astronomers, many of our friends, was because on the one hand, you had this incredibly esteemed astronomer, Avi Loeb from the Harvard-Smithsonian Center for Astrophysics, the person who's called in to do the most complicated simulations of black hole event horizons and really knows his stuff, was put his name on a paper that said Oumuamua could be a solar sail, could have come from another, alien sent a solar sail. That's not what they claimed. But they said, pretty much that you couldn't rule it out. And
this is where we have to remember that sometimes the brightest among us can do stupid things. There was a paper, for instance, a few years ago where someone discovered this amazingly bright transient object that was there one night, wasn't there the other nights. And it turned out a cosmologist had discovered, I believe it was Mars. It was just a matter of you have this esteemed scientist.
Didn't other people pretty congratulate them in sarcastic ways for discovering, or they had even come clean about it?
Exactly.
Turns out I just discovered Mars. Yeah. We discovered Mars. Yeah.
And in this case, it's the issue of, well, sometimes the universe creates things that kind of act the same way a solar sail does. And this object has a massive surface area to mass ratio, where if you want to fit as much mass in as small a surface area as possible, you use a sphere.
Right.
And the more you move away from something being a sphere, the more surface area you end up with.
Right. Well, and if I understand properly, like the explanation that most people had for the motion that the object was having was comet outgassing.
Yeah.
And what Loeb and Bialy were proposing was, what if it was solar pressure? What if it was the radiation from the sun was causing it to have an acceleration away from the sun that was in addition to what it would normally be doing? And the only shape that would match both the light profile that they saw and the motion that they were measuring was something that was millimeters thick but hundreds of meters across, aka maybe a solar sail.
Yeah, no, this is just an object that probably had some outgassing, that definitely had a surface area to mass ratio that encouraged the sun to push it along on its way. And these are the kinds of things that asteroid astronomers take into account all the time.
And this was the most recent example of the, I'm not saying it's aliens, but it's aliens.
Tabby star.
Right, and Tabby star was the previous one when we went through this whole thing where we saw this mysterious light profile that was coming from this weirdly dimming star, and one of the possibilities that had been suggested was that it was an alien megastructure. Cue the,
I know.
You know, that part of it.
And it's kind of awesome to think about these things and to imagine. I got to be on a panel at DragonCon with Larry Niven, who wrote Ringworld, and discuss all the concepts behind alien megastructures.
Yeah.
But the thing is, the universe keeps proving itself to be far more creative in what it has within it than science fiction writers are in making up stuff that humans are responsible for, or little green or gray or pick a color men are responsible for.
And so I guess where everybody got so frustrated by the paper that was done by Loeb and Bialy about Oumuamua was that it can always be aliens, right? That anything that you discover in space that you don't understand what it could be, you could come up with a mechanism for how it could be aliens. Where did that explosion come from? It was aliens. Where did those pyramids come from? Aliens. And so once you make an assertion that it's aliens, without any evidence to prove that it is aliens, then the assertion is kind of meaningless because you don't have any evidence in its favor.
And the same can be said of magic, of ghosts.
Yeah.
And it brings me back to as early as Galileo, when he was trying to explain momentum and friction, because friction was a kind of new idea in terms of putting it scientifically, and there's always this force when you have two surfaces meeting. And in discussing it, he had one of his characters talking to another about, well, what if it's just little demons pushing back and forth? Because you can always have a supernatural. It's turtles all the way down.
Right.
And this is where, if you want to prove something is a ghost, is a demon, is an alien, you have to have extraordinary evidence and rule out everything else.
And so is that really the heart of what the critique is? Is that they could have said, like, it could be solar pressure, and what are some different kinds of shapes and structures that could explain the solar pressure?
Exactly.
And leave it at that.
And this is where they essentially made themselves very, very good science fiction science advisors. This is the kind of thing.
Right, of course. If they were making a science fiction show, that would be the profile, and that's how the detections would be made.
And in the absence of complete data, you can always come up with, well, what is the technology that would explain this thing I have partially observed? When you have a partially observed system, we can't see Tabby star in amazing detail. We can't see it historically in all the different wavelengths we might want to see it in. In the absence of complete data, you can always come up with a mechanical solution that in some form or another explains away this natural phenomena. But often, if you have that full data set, if you have that complete observational understanding, it ends up to be something much more simple than building a solar sail.
And Tabby star, the follow-on to that is it's turned out to be a big cloud of dust.
Yeah.
And as most people were anticipating, and finally they were able to make good enough observations. With Oumuamua, there is an opportunity to make better observations. It would just require a level of engineering and willingness to hurry.
Yes.
To get to assemble the rocket, assemble the spacecraft, fire it off at a very high velocity, and try to catch up with it over the next decade.
Yes, and that's probably not going to happen.
It's not going to happen, no.
But at the same time, we do have the capacity to say there is this suite of different things that can explain what we're observing. And the responsible way for a scientist to report on this is to say, isn't it grand that we could explain it with a solar sail? But while that's cool to imagine, here's all these other things that nature does. Mm-hmm. And that's the responsible thing to do. And
so what is really different from respected astrophysicists writing a research paper and submitting it to, I think it's going to come out in the Astrophysics Journal. I think it's
one of those that doesn't have embargoes.
Yeah. So I think it is going to come out in a proper journal. So therefore legit science. Mm-hmm. And someone who thinks they saw a UFO. Right?
The difference is the maths. So
if you did like really great math on your UFO sighting,
then we would call you a theoretical physicist and publish the paper, and people would make fun of it.
And people would make fun of it, yeah. So you're not getting away from that part.
And all because something goes through peer review doesn't mean it's the best solution to a problem. It means it's a solution that you can't refute.
Right.
And that's what comes into this. It's one of many possible solutions for the observables. That doesn't make it the best. It doesn't make it the one that's canonically understood to be true. And this is the kind of thing that crops up in science all the time. There was a period of time where the canonical explanation for why we see galaxies and clusters moving the way they do, the reason we see stars moving the way they do, was dark matter, but we couldn't rule out modified Newtonian dynamics. And so there were two different theories, and a responsible person would say, this is the generally accepted primary theory, but we can't rule out this other thing. And this is where I have to acknowledge string theory can explain without excluding or predicting a lot of what we see in particle physics. And you acknowledge the theories that can't be eliminated when they accurately describe the situation until you can rule them out.
Right. And it's that excluding process, like everyone acknowledges all of the theories, probably sorts them in their mind from most likely to least likely.
And most cool to least cool.
And most cool to least cool, yeah. And I think that's why it could be aliens has jumped to because it is most cool. It is most cool. And so you have to balance on you're sort of imagining that two-dimensional grid, right? Where you've got on one axis you've got cool, on the other axis you've got likely. Yeah. And you've got, unfortunately, Oumuamua solar sail as extremely cool and extremely unlikely.
Yeah.
Which is essentially the not likely part you really want to focus on.
I know.
As opposed to the cool part.
Yeah, and the most likely is it outgasses, which doesn't even sound cool. It's essentially farting.
Yeah.
And that's just not pleasing.
Right.
It's just not pleasing.
But, the other half of this topic that we're talking about here, we talked about it's not aliens. And so just to be clear, literally everything that's ever been said that anyone has thought is aliens is not aliens.
Is not aliens.
Right. But because the cool factor on that scale is so high, astronomers are putting a tremendous amount of energy in attempting to actually find aliens.
Yes. And I can't say that we're going to find intelligent life anytime soon, but I'm right there with all the folks that desperately hope and want, and that doesn't mean it's true, for there to to be life under the ice on these moons that have liquid seas, that wants there to be life in the caves and lava tubes on Mars. I want there to be life, not necessarily intelligent, that's a little bit scary.
Right.
But I want to find those alien worlds with the oxygen-rich atmospheres that are indicative of something chemically going on. And I'd even be cool with being able to identify an industrialized civilization far away.
Far away, right. That's very nice.
Far away.
Far away, yeah. And so, I mean, I think that because it's the super cool but also unlikely, a lot of people are concerned that it's not a scientific question. And, I hear that a bit, that the funding for extraterrestrial, like, say, the SETI programs and things like that is actually pretty lacking because not a lot of people consider it to be a serious scientific undertaking.
And this is where I think the astrobiology institutes that are working to study the most extreme life here on Earth in the context of trying to understand what is possible out there, so that when TESS starts spitting planets out at us, assuming we have something to do the follow-up.
Yeah, come on, James Webb.
Yeah, we want to be able to say we know life can exist in these kinds of previously not considered habitable regimes of ice, of heat, of radiation, of acid. And by exploring the extremes of our own world, by identifying the life on our own world, first of all, it has a really cool spin-off of, hey, there's stuff out there that eats radiation. Go team. But at the same time, that starts to tell us it's worthwhile doing the slow, methodical, detailed work, studying these extrasolar planets in case there could be life there.
And I guess because the question is so important, because the ramifications, you said it's kind of scary. It goes back to that Arthur C. Clarke quote that either we're alone in the universe or we're not. And both result would be equally terrifying.
Yes.
That if we are alone in the universe, to as far as we can detect, then that tells us that the fact that life formed here on Earth is a possibly unique event in the entire history of the universe.
Which breaks all of our cosmological principles.
Well, for sure. And means that the responsibility is on us to not mess this up. That if life formed one time in this vast universe and on our watch, we wrecked it and then it never was able to become spacefaring and then the sun heat up and then everything died, that would suck.
Yeah.
To have this whole universe that could have had life in it and it came and then it was mismanaged by one stupid ape and then it was over. And that feels terrible. And then on the other hand, to find the life out there says, okay, whoa, we aren't the only ones alone in the universe, and some of it could be hostile, and some of them could be nice, and some of them could want to eat us for breakfast. Like, then you imagine every single alien invasion scenario, and that's terrifying.
Yes.
So both are terrifying.
Yes.
And yet, it's like the most important, fundamental, existential question we can ask.
Astronomy is really the observational form of philosophy sometimes.
Yeah.
Because those fundamental questions of where did we come from and how does it all end are scientifically the questions that we're getting at with trying to understand the origins of our universe, the evolution of our universe, and our place in the universe. And how did not only our solar system evolve, but all the other myriad solar systems out there that we're now discovering. Alma, I don't think a week goes by that there isn't another paper on, look at this amazing disk system around this young star. And as we get more and more observational data, when we don't see life, it's that quote, it's from Carl Sagan, it's an awful waste of space as well. And philosophically, that starts to be like, well, what?
Yeah. And then the funny thing is that we are in our lifetimes, the technology is coming online that should be able to give us that answer. Mm-hmm. That there are the searches for life within the solar system and the searches for life in the larger universe, which will tell us fairly comprehensively, have a really good shot at answering this question.
And that is both wonderful and terrifying. And because this is the episode where we quote everything, I'm reminded of Fiddler on the Roof, keep them good and well and far, far away.
I keep bringing up, and I'm sure I've mentioned this in the podcast before, this, one of the next generation telescopes that are in the works right now. Well, there's the extremely large telescope that's under construction now, which is the next step from the very large telescope. Yes, we know the names for the European Southern Observatory is very on the nose, but it's a 39-meter telescope that will be able to directly image the atmospheres of other planets around other stars. From the surface of the Earth,
yes.
It'll do this.
Yes.
Right? And there's the 30-meter telescope, and there's the Giant Magellan telescope. So 3 huge telescopes coming online in the next, say, decade. There's the space-based ones, James Webb, which we've talked about.
W first if it gets completed.
Let's hope. And then the follow-on, the next generation ones after them, leading up to potentially the LUVOIR telescope. And this is the number that I really love. I've interviewed Bradley Peterson, who's leading the development of this telescope right now. And he was saying that LUVOIR will be so powerful that it will be able to survey the atmospheres of all of the planets within a big enough sphere of the Earth to tell us with 90% accuracy, if it can't detect any life on any of those, that whether or not we are alone in the universe. So we are one gigantic telescope away from knowing to about 90% whether or not we're alone in the universe.
And this is where it becomes so important to see NASA and ESA and JAXA and all of these different space agencies working, because we are in this weird place where James Webb and ALMA and Curiosity for so long have consumed so much money in their production. And now we're looking at a new generation of ground-based telescopes being built, Large Synoptic Survey Telescope.
Yeah.
But we don't have that next generation of space-based telescopes that are actually in the clean room being constructed.
No, James Webb is the most mature, W first after that, and then it's just ideas.
There's nothing.
Yeah.
And so I want to see this stuff in my lifetime.
Yes.
Far, far away.
Well, no, 2035 is the plan.
No. I want to see the life far, far away.
Oh, I see. But no, but the fact that, even to think 2035, that's still, close to 20 years away from now for some of these next generation telescopes after James Webb, which, Hubble is closing in on 30 years old now, right?
I know. And James Webb, how many years ago was it supposed to have launched?
Forever, I don't know, 10 years ago,
8
years ago.
And now we're looking, earliest launch is
2021?
March 2021.
Yeah.
It's March 30th, so it's in Q1 of 2021.
Oh, okay. Right.
So, yeah.
Yeah. So then, what kinds of evidence would be the one that would make the scientists and the astronomers cheer in anticipation of the outcome? What key piece of evidence should we be looking for to go, we said that it's not aliens, it's never aliens, until it's aliens.
Right.
When can we go, okay, yeah, it's aliens?
So if you're just talking the single cell, double cell, tiny stuff, we need to see things that reproduce and act in all the ways you expect little tiny biologicals to work. And we're only going to see that in our own solar system. For other things, the key factors that we're looking for are chemical systems that are out of balance in a way that has no explanation other than life. And Peter Ward has made some amazing cases for we don't even know what we don't know. So with the astrobiology institutes that are out there, they're systematically describing this chemical out of balance is indicative of this life. This chemical out of balance is indicative of this life. This is just pollution, which is life.
Yeah.
So I think in order to say there's intelligence out there remotely without seeing it actually flying around, we're going to have to see pollution, essentially.
Right. Some kind of unstable chemical signature in the atmosphere of a planet.
And that will allow us to say there's intelligence out there through indirect means. And beyond that, we can say there's life out there through indirect means by just looking for not just the superfluous methane that keeps making us go, well, it could be geology.
Right.
But looking for other chemical out of balance signatures like oxygen. But the tantalizing thing that I really don't think is going to be how we find life first is that directed laser light with prime numbers,
right.
That directed radio signal, all the things that the book Contact detailed.
And so that's the work that, say, the SETI Institute is doing.
With their Allen array.
With their Allen array, and just this idea of you're looking for some intelligent message that's being directed towards Earth. It's a long shot, but if you get it, then it's a slam dunk.
And we do have to acknowledge there's lots of good other science. So the SETI Institute is doing astrobiology. They're part of the Sophia Observatory. There's lots of really good research going on out of SETI. It's not just looking for little green men. It's doing all of the stuff necessary to go, this is what we have to see. And this is the science we have to perfect, the techniques we have to perfect in order to identify that life out there in the universe.
Yeah, it is a really exciting time. And it feels, over the last couple of years, it's really felt like the astrobiologists are starting to get a lot of respect from the scientific community for the extremophiles they're finding here on Earth and the techniques that they're pioneering to try and find life on other planets. A lot of this is being put into practice on Mars, with especially the Mars 2020 rover and other stuff following of that, as well as these observations that are going to be made. Finally, the tools have shown up that will allow them to make these kinds of observations. And so now, it's a chance to get some kind of validation to their study.
The realization that there are worlds out there in such great numbers really caused a shift in priorities for research. Prior to 1995, we had no certainty that regular stars had regular planets, and it took a little while to find regular planets. But in 95, when we started finding the super Jupiters, the hot Jupiters, it was this moment of, we need to put new resources into new ideas. And in the late 90s, early 2000s was when astrobiology became a term, a word, a thing that was funded, and it's becoming I wouldn't say a mature science, but a defined science that has best practices and the ability for grad students to carve out this extreme environment is mine, and really make a name for themselves in cool and rigorous ways.
So do you think that we will find evidence of aliens in our lifetime?
I hope we find evidence of life forms, but in our lifetime. And the intelligent one just gives me heebie-jeebies.
Yeah, I didn't specify intelligent.
I know.
Yeah.
I want to find the lichen on Mars.
Yeah.
I want to find the bacteria living in the cryovolcanoes.
Right.
I want
the
that
evidence
to be...
that there's something on Epsilon Eridani.
Well, that's harder, but I want to know, does life require DNA? These are the questions that I want answers to.
And if life is found, then that's just the beginning of a whole new series of questions. How does it work? How is it different? How is it the same? Where did it start?
And this is why we do science. It's because we don't know the answers. Scientists don't know everything, but damn it, we want to.
Right. All right. Well, Pamela, thanks a lot. Again, great to hang out with you in person. We'll see you next week when we're remote again.
Sounds great, Fraser.
Thank you for listening to Astronomy Cast, a nonprofit resource provided by Astrosphere New Media Association, Fraser Cain, and Dr. Pamela Gay. You can find show notes and transcripts for every episode at astronomycast.com. You can email us at info@astronomycast.com, tweet us at astronomycast, like us on Facebook, or circle us on Google+. We record our show live on YouTube every Friday at 1:30 p.m. Pacific, 4:30 p.m. Eastern, or 20:30 GMT. If you missed the live event, you can always catch up over at cosmoquest.org or on our YouTube page. To subscribe to the show, point your podcatching software at astronomycast.com/podcast.xml or subscribe directly from iTunes. If you would like to listen to the full unedited episode, including the live viewers' questions and answers, you can subscribe to astronomycast.com/feed/full-raw. Our music is provided by Travis Searle, and the show was edited by Chad Weber. This episode of Astronomy Cast was made possible thanks to donations by people like you. Please give by going to patreon.com/astronomycast.